Hi, welcome back to another episode of FRC Robotics 101. I'm Tang, and now I'm bringing you my worst nightmare, the process that ruins my functional schedule, the thing that the more time you spend on it, the more flawed it seems. In this process, one mistake will set you back hours of work. It's going to be torturous, so let's strap yourself to the table and let the pain begin.
Okay, so let's hit it off with the easiest thing in the world, pocketing. Because this part of the CADing process is basically just finishing up your robot and maybe integrating your backup plans. You want to get in all of the details. So one of the things you need to consider in your competition is like things like weight and size. Basically, if your robot is a bit over in weight, you need to do pocketing. Pocketing is just the act of cutting out parts of different extrusion and different parts of the robot to reduce the total weight. It can also give you a lot more space so that you can put in different parts, maybe like get an axle through somewhere, things like that. This can be easily done with things like hand drills. You can just cut out some circles, and that will be the first thing I teach you here, just how to draw out circles. This might seem simple because, well, yes, pretty much it is very simple, but there are a few things that you need to consider. First, the points of attachment with different parts. The thing about this is that when you're cutting out things, you don't want to cut out parts that are too close to the holes that you're going to attach to different parts, because that will weaken the connection point. So first, you just zone out the area around all of the holes and attachment points. As you can see here, I'm drawing out some construction lines to just zone everything out. Then I can start drawing some actual circles. This basically is just a representation of what you would normally do with your hand tools. You don't need to put this in your CAD. Just it will be helpful if you just basically do it since the beginning. But there's nothing wrong with just using hand tools for that. Basically, if you're using hand tools or CADing it doesn't matter. You need your numbers to be the same as one of the tool bits that it's available to you. Or else you would need to do really stupid stuff like drilling and then using your drill to spin around, which will take a lot more time and will be a lot worse. And you don't want that to happen, so put in real numbers like 30, 29, actual numbers of tool bits. Just basically use the pattern function to copy off the circles around, make sure it doesn't interact with the area that you zone out, and that's basically it. This is the simplest way of pocketing. You can do it with hand tools, you can do it with CAD in like 2 minutes. It doesn't take a lot of effort, but it's not the best way to pocket. First, it's not the strongest way, and second, you don't get a lot out of just pocketing like this. It doesn't reduce the weight by that much. So that's why after this one, I will show you the next way to actually cut it out, the way that you're going to use when you're planning forward by pocketing in your CAD file. Okay, so now I will show you how to actually integrate pocketing into your CAD file. So one thing that is good with CAD file is that it's going to be used by CNC machines, which means that you can use the strength of different CNC machines. So when you are using hand tools to pocket, mostly you can only get to cut out circles. But if you're using CNC machines, you can cut out different shapes. And in this case, we're going to cut out triangles. Why triangles? First, cutting out triangles will make it actually a lot lighter than just cutting out circles. You can get out a lot more from corners. It's just a lot lighter. Another thing is that cutting out triangles makes it pretty strong, unlike cutting out circles. If you're cutting out until you have the same volume with circles and with triangles, the triangles is going to be a lot stronger. The thing is, when you're a triangle with the 3 different lines static, you define the length of all of those 3 lines, all of the angles inside cannot be changed. It will be static. You cannot do anything about that, which makes it a lot stronger. It's evident in things like bridges and different structures. You just see triangles to support things basically everywhere. So first, just define the place that you want to cut the materials out of. In this case, I will just cut out one corner of it because the rest will be basically the same. So first, define the middle, draw a line that is going to be 60 degrees from one of the sides of your extrusion, and then just start drawing out the triangles. The only number that you need to define here is basically how thick you want the sides of the triangle to be. So in the case here, I put a side as 5mm because it needs to hold quite a bit of load. So then you just start drawing out triangles. It's going to be regular triangles, which means that all 3 angles are going to be 60 degrees. So you just want to draw out 2 triangles that are going to be mirrored through the point in the middle of the part that you're going to cut out, and then just start linear patterning, or also called rectangular patterning, it to 2 sides, and then just cut it out. This is the actual way to integrate pocketing into your CAD. You can see it used by a whole lot of teams. Every team cut out different triangles. That's just what everyone does, so why not also do it? Next, after you're done with pocketing, you also have the concern of durability. So of course, there are going to be parts that will receive significantly more stress than others, since not every part supports the same amount of things, and not every part moves around in your system. So for support, just support the parts that are connected to the base because they will bear a lot of load. They basically need to carry the whole weight of your robot. Also, support parts that are going to be directly attached to some spinning axles because they are going to move around a whole lot. There's going to be a lot of backlash. They will get loose very easily from constant movement, so please support them. And another thing that you need to support is parts that are overhanging a bit too much. Basically, just count the number of parts in between that thing and your base. If it's larger than the numbers of every other part, probably it will need support. So generally, everything will have a bit of backlash, and the further away it is from the support, the more backlash it will have, which will be a really bad thing because it will mess up with your calculation a whole lot. So you need to support all of these different parts to minimize backlash, to minimize damage to your robot. So I will now name some things that are normally used for support. There are going to be guides, flanges, and gussets. So guides are things like grooves or sliders that will help your mechanisms move around a whole lot. So basically, it's similar to that thing that we drew in episode 6, the second part of the first CAD episode. So basically, guides are things that will help you move around, but will also limit your movement in a certain area. So as you can see here, is basically just a groove so that you can slide things along. Then you have a gusset. A gusset is basically just a sheet of metal that is used to connect different parts. It might seem simple and might not seem very important and very impactful, but the thing is that a gusset is not that heavy and you can get a lot of them out. Basically, there are robots that are just connected with a whole bunch of these. There are bays that are just a whole bunch of these connect together. The strength of this is in numbers, and the places that you can fit it in is smaller than integrating guides, is smaller than integrating different support mechanisms like just a support beam or flange. That's why it's very useful. Basically, if you see two parts that are close to each other or on the same plane, you can connect those two with a gusset. Lastly, you have support beams or flange or whatever you want to call it. This is basically the simplest thing that you can use for support. Just pump out, well, a whole beam to support that part. Basically, like I said before, you don't want parts to overhang too much. So why not just use like a huge support beam to just connect that part to the base? That is very simple. It's a very direct change, but normally you would not want to use this too often, because if your robot have like 20 different support beams, it's going to be very heavy. So basically, you only need like 3 or 4 of these around your robot to support the whole thing, and then just connect everything to that. General rule of thumb here is just make it so that every part is not too far apart from these support beams, and because of that, not too far away from the actual base of the robot. Another thing that you're also considering when making support parts is that you need to lock your whole robot in different directions. So that means basically you don't want it to be able to wiggle in different directions. You do that by integrating all of these different support mechanisms that I've said in different parts. So basically, if you connect 2 parts with a gusset, normally they can move around the same plane that they share quite easily. They just need to move. You just need your robot to run around a bit, and it will be pretty loose, and then it will be able to wiggle on that same plane. But after that, if you can again attach something like a support beam between different corners of that, they will limit their movement in that plane a whole lot. So basically, just integrate different support mechanisms so that it will lock your whole robot in different directions.
Yay! So that's it for this episode. It might not seem as bad to you viewers, but I can assure you that doing the real thing really sucks. I'm just thankful that the whole thing ended. PTSD. So that's it. Thank you for watching and listening. See you next time.